Hi, this is Santanu Santra. Welcome to my video again. So, today I will discuss about work. What is work? Work is done when a displacement occurs under the influence of a force. That means, suppose there are some obstacles there, and if we apply a force, and by that force, if there is some extent of displacement of that wall or anything, then we can say that the some work has been done by that force. So any work we can express by two factors. Number one, intensity factor, and number two, capacity factor. So what is intensity factors, or we can take abbreviation as IF, and capacity factor as CF. So intensity factor is the extent of opposition. Intensity factor is the extent of opposition. And capacity factor is the capacity to overcome that opposition. So by the help of these two kind of factor, we can express work properly. Now we can write as work equal to intensity factor multiplied by capacity factor. If this is mechanical work, then we can write as intensity factor is the force, and capacity factor is the displacement. Now if we write, then W equal to force into displacement dl. We know that force equal to pressure into cross-sectional area. Now area into displacement is the volume, so P external into dV. That is the basic relation between work and pressure and volume. Now as there is small amount of volume change, so we can write as dW, and here is one extra negative sign. So why this negative sign is used, I will talk about later. Now IUPAC convention for work. IUPAC convention. According to IUPAC, the expansion work is taken as negative, and compression work is taken as positive. So what is the reason behind this? Because in case of expansion, what happen? The work is done by the system. Work is done by the system. How? Suppose we are considering 1 mole of an ideal gas kept in a cylinder covered by a weightless and frictionless piston. Right? So here P internal is acting from the lower side of the piston and P external is acting from the upper side. When P external equal to P internal, the piston will be remain in the same position. But if there is some sort of what to say, if P external not equal to P internal, greater or less, I will talk about that later, that if P external is not equal to P internal, then there can be expansion or compression. So if P internal is greater than P external, then what happen? This pressure is greater, then the piston will go to the upward direction. That means expansion will happen. That means expansion will happen. So for the expansion work, the P internal is the driving force. That means the work is done by the system's pressure, or we can say that for expansion work is done by the system. As system is doing work, that means system's energy is consuming. That means work is done by the system at the expense of system's energy. That means the total energy of system decreases. That means for expansion work the system's energy decreases, and according to IUPAC convention, if energy of the system decreases, that is considering as negative. That is why for expansion work it is taken as negative. Now for compression work, so if P external is greater than P internal, then what happen? P external is greater than P internal. That means the piston will be lowered down and compression will occur. That means for compression the surroundings is doing work. That means work is done on the system, right, by surroundings. That means surroundings energy is decreases, and which is stored in the system. That means the energy of system increases, and that is why the work is taken as positive. So compression work is positive. Now heat. What is heat? Heat is one kind of energy that flows from hotter body to colder body when they are brought into contact with each other. Suppose this is a hotter body and this is colder body. That means temperature of that body is greater than temperature of that body. So when these two systems are brought in contact with each other, then what happen? The energy from the higher temperature body will go to the lower temperature body. So that kind of energy transfer is called as heat transfer. That means we can say that heat is one kind of energy that transfers from hotter body to colder body, from hotter body to colder body, when there is a inequality of temperature and they are in contact with each other. So what is the IUPAC convention? Here we can write IUPAC convention for heat. The absorption is taken as positive and rejection, or we can say that if system reject heat, then we can say it is negative, or emission. Why? Because if system absorb energy from surroundings, then total energy of the system increases. That is why positive. And if system reject energy to the surroundings, that means the system's energy is going to decrease. That means this is negative. So what is the molecular interpretation? Molecular interpretation of heat and work. And work. Heat and work. What is the molecular interpretation? Heat is disorder motion of energy, and work is ordered motion of energy. When there is a disordered motion of energy, then we can say that there is a heat transfer is going on. How? The system which is hotter, the stimulation, that means we can say that the motion, thermal motion of the molecules in a hotter body is more than the motion, thermal motion of the molecules in a cooler body. Then what happen when two systems with unequal temperature are brought in contact with each other? The molecules in the hotter body stimulates the molecules in the colder body. Again I am repeating, the molecules in the hotter body stimulates the molecules in the colder body to vibrate more and more. That means the energy is transferring from hotter body to colder body in a disordered manner. That is why heat is termed as disorder motion of energy. Now, what is work? If there is some sort of ordered motion of energy, That means if we are considering an ideal gas kept in a cylinder covered by an weightless and frictionless piston, then in order to do some expansion or compression work, the piston has to go to that direction or that direction. So if the piston is going to that direction, that means all the molecules of the piston, and if we considering only the ideal gas as system, the all the molecules of the ideal gas are going in a ordered way. That means all the molecules are going in a ordered way, not zigzag way. That means in compression or expansion work, there is a ordered movement of the molecules, right? Now mechanical work. So if there is any kind of work related to pressure and volume change, then we can term as this is a mechanical work. Mechanical work means PV work. That means pressure and volume related work. So suppose there is n moles of ideal gas in a cylinder covered by a piston which is assumed as weightless and frictionless. So inside that there is n moles of ideal gas. Initially at P1 pressure and V1 volume and T temperature, and this is undergoing expansion or compression at isothermal condition, at constant temperature condition, isothermal condition. So for the final state, the pressure is P2, volume in V2 and temperature is T. Now if that change, I mean from P1 V1 T to P2 V2 T, that change occurs via reversible way or irreversible way. I mean there are two type of possibilities: reversible work and irreversible work. So in both cases the expression will be different. That means if the change takes place through infinite number of steps, and in each step there is infinite small changes in the properties, in the parameters, then we can say that this is reversible way. And if that takes place through one step or finite number of steps against the constant external pressure, that means there is a irreversible change. So now if the process is taking place by reversible way, we will derive the equation. For general we can write as, if there is small change in volume, then dW equal to force into displacement. dl is the displacement of the piston and F is the force, or we can write as F is P external into A into dl. And there was one negative sign. So why this is negative sign? I'll clear about that. Now A into dl equal to, we can write as dv, that means change in volume. Now why this negative sign is used? Suppose for expansion or compression, we can write that full expression as W equal to minus P external V2 minus V1, like that only. Then what happen? If there is expansion, then V2 should be greater than V1. That means expanding, the system is expanding means the volume of the system is increasing. That means this term is positive. And we know that according to IUPAC, the expansion work is negative. So in order to make that, we have to put one negative sign there. And also for compression, V2 is less than V1, then this is the negative term. But we know that according to IUPAC, the compression work is taken as positive. Then in order to make that term positive, this is negative, so we have to put negative sign. That is why in thermodynamics, basically in chemistry, whenever we are studying thermodynamics, there is a negative sign in the work's expansion. Now for reversible work, so the work's general expression is like that, dw equal to minus P external into dv, right? So if the complete changes occur, then the expression for work will be W, which is the integral of dw. That means we can write as integration of minus P external into dv. That is the work's expression. Now for reversible work, what happened? Now the difference between the external pressure and the internal pressure is very, very small. So we can express external pressure as internal pressure plus minus some kind of small pressure, as the difference between two terms is very, very small. So then we can write as W equal to minus P internal plus minus dP into dV, or equal to minus P internal dV minus, if we multiply, that is minus plus dP dV. Now the second term is very, very small. Okay, here is so we can write as this almost nearly equal to that term, P internal into dV, because we can neglect that term. This is the multiplication, or this is the product of very, very small two terms, right? So then W reversible we can write as minus P internal into dV, and as the integral is dV, then the limit should be V1 to V2. Initial is V1 and final is V2. Now for n moles of ideal gas, we can write as P is equal to nRT by V, right? Then if we can substitute that value, that becomes V1 to V2 nRT by V into dV. As we are taking the isothermal condition, and we know that there is a no change between the number of moles between system and surrounding, so N is constant, R is constant, T is constant at isothermal condition. So minus nRT V1 to V2 dV by V, that means ln V. So minus nRT, if we put the limit ln V2 minus ln V1, that means ln V2 by V1, right? And we know that for isothermal condition P1 by P2 equal to V2 by V1, because P1 V1 equal to P2 V2. At isothermal condition T constant, that means RT constant, then P1 V1 equal to RT and P2 V2 equal to also RT. Then we can write as W reversible equal to minus nRT ln V2 by V1 or minus nRT ln P1 by P2. So this is the general expression for reversible work for a ideal gas. If we take van der Waals gas, then what will be the expression? Now for van der Waals gas, so we are here W equal to minus V1 to V2 P internal into dV, right? Then for van der Waals gas, for n moles of a van der Waals gas, we can write P internal plus n square A by V square into V minus ND equal to nRT, right? So here P internal equal to nRT by V minus NB minus n square A by V square. So if we put that value, that becomes V1 to V2 nRT by V minus NB into dV, and then minus into minus plus V1 to V2 n square A by V square into dV, right? Equal to, we can write minus at constant temperature nRT is constant, so dV by V minus NB ln V minus NB ln V2 minus NB by V1 minus NB, right? And there is plus sign. Now A is constant, n square is constant, n square A. What will be the sign here? Integration dV by V square produces minus 1 by V. So minus into plus, that is minus. So 1 by V means 1 by V2 minus 1 by V1 in bracket, right? So this is the expression for a reversible work for an van der Waals gas, right? Thank you for watching this video, and the later part, that means the work for irreversible process, will be discussed in the next lecture. Thank you. Subscribe my channel Chemistry Club.